Next comes Calc. I described some of this stuff in the overview talk. I'll go in a little bit more detail this time. So Calc has support for evaluating expressions at runtime, and all of this stuff is based on the calc out record that's in Epic's base. That's what I did was I started with a copy of the calc out record, and then I just diddled it until it did the stuff that I wanted it to do. So, and we ended up with 4 records that are based on calc out, and 1 record that's based on the sequence record that's also in Epic's base. And I'll describe those records. And then there's some other code for interpolating and for averaging, and there's some code to edit sequence records. And most of these records also allow you to specify to wait for completion. The calc out record doesn't have this, and I don't think there's a record in base that does this naturally, although you can do it with soft async device support. I think you can make any Epic's record do that. The transform record is the one that doesn't wait for completion. All the other ones can. You can specify whether they do or they don't. So also Calc contains databases and display files. It's got display files for basically all kinds of calc records, including the calc records that are in base. And also the sequence record that's in base is a display file for that. And, but mostly what it's got is documentation on what expressions are legal and what they do. So for all the expressions in, I think, all the calc records that exist, they're all documented like this in a runtime form. So the array calc record, it looks just like the calc out record, except we have these 2 fields here. There are actually 10 of these, and I'm only displaying 2 of them. Array valued fields. So these links, if they point to an array valued PV, you will get the array in this field here. It'll only display the first element of it in this field. If you want to see the rest of it, you can open up a plot by clicking on this green button here. If it's a scalar, it will just have an array. It will make an array out of n copies of that value. Oh, and the other thing is that most of these records also have an additional output option, never. This really doesn't make very much sense for the calc out record, because the idea is that you're going to be doing this in a database. And in a database, if you really wanted to select never, God, if you wanted to select never, it'd be simpler to just not put a link in there. Easy to have never, right? But for runtime use, it's really convenient to be able to disable the output of this thing every once in a while. So here are some typical array expressions. Let's assume, for example, AA, which is this PV right here, has the value 1, 2, 3, 4, 5. And so you can take a substring of that. Is that a minus? Okay, that's not minus AA. That's really intended to be a bullet point, all right? So there aren't minuses anywhere. Okay, so this expression just takes a substring, 2, 3, and 4. There is also a way to take a substring but leave it in place, and then you would end up with 0, 2, 3, 4, 0, 0, 0. So you can do that with curly brackets. X is an operator that stands for this array, 0 up to however many elements are in the array calc record. And that's useful if you ever want to have, it stands for index. And so if you wanted the sign of something, you could just say sine of x times degrees to radians, and then when you plot it, it looks like this. So it's a pretty handy way to. There's a whole bunch of other functions I'm not going to show you. We could walk through the documentation if you like, and I'll go through some of those things at demo time. So the string calc is almost the same thing, except instead of arrays, there are strings. Instead of array expressions, there are string expressions, and some of those things look like this. You can do printf. So if you're driving a voltmeter or something like that, you can construct a command that is probably not going to be ABC 1, 2, 3, but it might be something like that of that form. So you can make that stuff with a printf statement. You can also pull out substrings this way, and you can do replacements this way. So if you wanted to replace .val with .egu, this expression will do that for you. The transform record is pretty much like 16 calc out records, except they all share the pool, a pool of data values. So for a calc out record, you've got 10 input values in one expression. Transform record has 16 input values and 16 expressions that all use all of those values. And it also has one other thing. It has a prescribed conditional execution of the expressions. So if you were to write to this field, which is the C field, and tell the record to process, it will go here and execute this expression and this expression, but it won't execute this expression because that would overwrite what you just did. All right, so that's what the conditional evaluation is all about. And this is intended to do coordinate transformations and support slits and mirrors and things like that. And the most recent addition to the transform record is illustrated here. And I'm sorry I don't have a copy of what it looked like in the olden days when all the expressions were A minus D over C. It was impossible. It was impossible to understand what a transform record was doing. Well, it wasn't impossible because we did it, but it was really hard to understand what a transform record was doing, and it was even harder to edit a transform record. But now what you can do is if you specify at the beginning of a comment a $sign followed by any string, that becomes a synonym for that variable. In this case, $xpos, which is the positive side of a two-edged slit, is a synonym for A in all of these expressions. So these expressions can be a lot easier to understand than was true back in the olden days. And I think the Calc out record actually has this capability also, although I don't know how you specify which string is associated with which variable. So the string sequence record is like the seq record in base, but it can read and write strings. And it decides by the type of the PV that it's reading from or writing to. So if it's reading from a BO record, that's actually a string, even though you might think of that mostly as a number, but that's actually a string valued field. And so you will get the on, off, or stop, start, or whatever the Z name and the O name are for that record. So for any string valued field, it grabs a string and it shoves it here in the string value, and then it converts that into a numeric value, and the numeric value of anything that doesn't look numberish is just 0. And then on output, again, it looks at the type of the PV that it's connecting to, and if it's a string, it's going to write this string value. And sometimes this can get you into trouble because we're used to doing CA puts to a BO record or an MBBO record and just writing the number. And you actually can do that, but if you tell it that you're writing a string, then you have to write a string, and that's what this record does. So that's a little bit inconvenient if you're writing to the start field of a multi-channel analyzer or a multi-channel scaler. You have to be careful. So this is also an example of what's going to come up later. This is a string sequence record running CA put recorder. I'll show you that. It's going to specify the name of the macro that it wants to run. It's going to specify an argument, and then it's going to actually execute that macro. The interp database does nth order Lagrange interpolation on a PV against an array of values. And it's pretty much like the breakpoint table in EPICS, except it's easily modifiable at runtime, and also the breakpoint table just does linear interpolation. So you need a lot more points in a breakpoint table if you want to have the same coverage. You can load the interpolation table from autosave or from an array calc record or any other way of writing an array, or you can build it point by point. For example, when we were, for example, you can write an X value and a Y value and then press add entry. And that adds one entry to the interpolation table. And you can actually do this with a scan record to add the X value and then figure out what Y value actually comes back and have the scan record push that button. And then when the scan's over, you've got a filled out interpolation table. It's pretty handy. There also is array mode. If you already have an interpolation table in here, you can write an array to this PV. It looks like the same PV as this one, but it's not. This is the array entry. And it will interpolate the whole array and output the whole array. And the last thing in the Calc module that I'm going to talk about is data averaging. This started with software that was written by Frank Lenks. It's a long time ago. And the way it works is you specify the number of samples that you want to average, and you specify whether you want continuous or one-shot averaging, and then you either arrange for this record to process by changing the scan, or you can do a CP link on some other PV that you're monitoring. And every time this thing executes, it will calculate the average of all of the values. And you can also, if you want in a scan to take an averaged value of some PV, the scan record can push this button, and it'll get a callback after the average has finished. And that way you can know that the values in the average are actually recent. They came from after the time that the scan record moved a motor, for example. Then you can click average, and it'll average up to 10 points and give you a callback when it's done. There are 3 algorithms that it uses for averaging. If the signal is just standing still, it doesn't make any difference. You just do an average, it's fine. But if this thing is in a feedback loop, for example, and the value is constantly changing, if you're in this situation right here, and you take an average over the last, let's say, 20 data points, the number you're going to get is this, and that's got nothing to do with the current value of that PV, right? So you can actually do a much better job. Instead of taking an average, fit this thing to a line, and then just evaluate the line at the current data point. So if you're putting this in a feedback loop, you probably want this. On the other hand, you're using the same number of data points to calculate 2 quantities now, right? The slope and also the average value. So the average is going to be a little bit noisier. So if the signal isn't moving, you don't want to do this. If there's no slope on it, if it just stands still, you really want to do an average. So that's why the third algorithm is here. This varies smoothly between just a straight average and a fit to a line, returning the most recent point, or the value at the current time. And it just uses the linear correlation coefficient to determine how far from auto to line fit it should be. So if it's a really perfect fit, this kind of a fit is going to be entirely fit line. But if it's all jumbly and noisy or mostly flat, it's going to be almost entirely average. So that's it for Calc. I'm going to move on. Any questions? They are in VDCT actually just looks at the database definition file. So anybody who adds a record, it's automatically going to be available to VDCT as long as you have it in the DVD file. Oh, I know what I can do. I can demonstrate edit string sequence. This is a new thing that see if I have a string sequence record with stuff in it. So this is what happens to me all the time. I get done writing a sequence of operations, and then, oh crap, I forgot. I have to add something in the middle of that. And because each line of this sequence can refer in complicated ways to other lines. For example, it can grab a value from the other line, or it can wait for some other line to complete, wait until some other line to complete. Editing this stuff at runtime is an error-prone process. And so I finally got disgusted and wrote this sequence program that will do it. And oh crap, really? Okay, you can't drag and drop on a Mac. I mean, there's a way to do it, but not the way this guy's set up. So anyway, what you need to do is drag and drop a PV, any PV from this record. And it turns out that this record so if I just drag and drop that PV, then it'll just strip the actual field name, because we don't care about the field name. But from now on, we're going to be editing this string sequence record. And I could say, for example, I want line 4 to go down 1 to make room for the thing that I forgot. And this guy will do it, and it'll adjust the weights, and it'll adjust the input links, and all of this other stuff. And anybody else who's referring to that, if somebody else was using a value that was grabbed by line 4, then I'll overwrite that, right? If I want to move it down further, I have to do 5. Right. What I really want is an undo. Actually, what I really want is multiple levels of undo. But I'm just not willing to put the time into that. And it's just not that urgent. I mean, this for me was pretty urgent, because I was orchestrating an experiment at Sector 2 with this kind of stuff. I had like 30 of these things. And it was, I just really couldn't do it without this. So, no, it's just, here's all the options. You can just say plus or minus, or you can swap 2 and 3 this way. Or you can say, you can use A for the A field, or for field 10. 0 and A are also synonyms for field 10. It only moves one line. Yeah, it doesn't move multiple lines. It'd be kind of nice, but I don't have a simple syntax to say move lines 4 through 7 down to, it wouldn't be that hard, but it would be fairly time consuming, I suppose. And eventually it'll probably acquire that capability, but right now it's usable anyway, as it is. So it's already pretty helpful. And this is all done with a state notation language program, which is the reason that Calc now depends on seek. So I guess I really ought to show a user transform. So I can have A plus B. Or I can change A to $red, I don't know, whatever. And then from then on I can use $red to refer to A, and I'll get the same result. So it's pretty handy. I think I'm one of the main users of transform records, so this is probably a little bit more exciting to me than it is to anybody else, but this is really exciting for me. Yeah, they do. I guess they do tend to get used quite a bit, and sometimes the expressions can get really hairy. And also the transform records expression is now 120 characters long, because you can have macro names or the variable names that are pretty long.